Hi, I'm Koki. I'd like to talk about running Stable Diffusion on mobile. Specifically, I'll talk about how to optimize Stable Diffusion model for speed and efficiency. So let's get started. So as many of you might already know, Stable Diffusion is open source image generation models. Technically, it's categorized as text-to-image diffusion model. It can generate wide range of diverse and high quality data. It was done with long training hours with a large number of GPUs. And then it was released with significant impact in 2022. So the image shown here is from Stable Diffusion XL. This is one variant of Stable Diffusion model released last year. So how can you use it for games? This research field is very, very active. So there are too many to list them all. So here are some just examples. First, there's asset creation. By using image generation models, there's a possibility to efficiently develop assets for games, right? Here we have shown an example of generating castle assets. Such designs might help designers in creating the final assets. Moreover, the latest research includes directly generating 3D models from text prompt. Also, in some cases, it might become possible to generate assets on the fly or create in real time. The next one is personalization, which involves fine-tuning techniques that can produce specific style or specific style of images. It can generate AI avatars, that wearing costumes that they wouldn't normally wear by uploading face photos. Also fine-tuning technique called LoRa. LoRa can be used to generate images in a specific style. There's also research on improving the controllability of generated images. On the left, control net technique uses text prompts along with laugh-doodle sketches or pose skeleton, or etc. to generate image based on these inputs. This allows for some degree of control over the composition of the generated images that couldn't achieved with text prompts alone. On the right, there's a technique that allows for manipulating the object in the generated images by using smartphone-like gestures like dragging or pinching, so which is interesting. So in short, Stable Diffusion can be used not only for accelerating game development efficiency, but it also enables expand your creativity. And then I'll talk about the model itself now. Since the first release of Stable Diffusion, it has undergone several updates. The graph shows how the number of parameters in the model has changed over time. With the release of Stable Diffusion XL, as you can see, the number of parameters significantly increased from 860 million to 2.6 billion. And also last month, Stable Diffusion 3 was released, which is bigger than that. The images below the graph show how the output has changed with each version. In general, the output from the bigger model is considered to align better with text prompt. So, this trend of enlarging models might continue in the future because, understanding of text prompt or size of generated images, visual fidelity improves with, increasing model size. So what will be the challenge when you want to run the Stable Diffusion model on mobile? There are two primary challenges to do that. The first challenge is that the model is designed to be repeated multiple times to generate images. This diagram explains the flow of Stable Diffusion. The text prompt is given as input on the left, and then the image is generated through three types of models: text encoder, diffusion model, and decoder. And then the middle part, the diffusion model, becomes the performance bottleneck. And then this model runs in a loop about 20 times for mobile, for example. So this is the first challenge. The second challenge is the complexity of the network architecture. as shown here, the diffusion model has very large number of parameters compared to the other two models. The breakdown of the model's architecture is shown here. So you don't have to understand the details, but the point is that the model is essentially based on an architecture called UNet. The input goes through several stages of downsampling and then upsampling, and then return the result in a size equivalent to the input. So this requires a huge amount of processing, computation. So this is the second challenge. So here we present some examples of optimizing stable diffusion model along the timeline. This graph shows our journey of optimizing stable diffusion, and then the vertical axis indicates change in performance when using ARM CPU, not GPU, on mobile. So you can explore picking up state-of-the-art from research, or reducing the model size by changing the data type from 32-bit floating point to 8-bit integer type. Also, you can employ techniques called quantization, pruning or distillation to decrease the model size or reduce the number of steps to generate images. For example, the model called LCM, or latent consistency model, it's recently published last year. It managed to reduce the number of steps needed to, image generation from 20 to just 4. And then it achieved about 4 times speed increase. With quantization, changing the data type from 32-bit floating point to int 8, it reduced the model size to quarter of its original size. And then it increased the execution speed more than 10 times faster compared to the original one. Furthermore, decent models that can generate images in a single step have also emerged. Combining these optimization techniques with such models can generate images up to 60 times faster than the original one. So yeah, in this way, by combining various optimization techniques with the latest models, significant speed improvement can be achieved. After quantization, you can check the accuracy of the model qualitatively and quantitatively. Qualitatively, you can visually check images generated by the models side by side. Quantitatively, you can use metrics like FID, Frechet inception distance, clip score, and IS, inception score, which are commonly used metrics for evaluating image generation models. The graph here shows the clip score before and after quantization. Blue is before quantization, orange is after quantization, and then higher the better. And quantization slightly lower the score, but the impact is minor. And maybe you can see that qualitative evaluation too. Maybe you can judge these results are acceptable. Finally, this is a comparison of the image generated by the original stable diffusion and also our model after all the optimization we have listed. As you can see, when comparing the results using the same prompts, we have achieved fairly good results comparable to original stable diffusion, but it's 60 times faster than the original one. So summary, image generation is gradually being used in games. This area is very, very active, and we believe this is not only increase efficiency, but it can also contribute to creativity. So we discussed the main optimization, which can dramatically increase the speed of image generation. This is especially useful for resource-constrained devices like mobile. Also, the technique I introduced today is not only for image generation, but it can be applied for any models. So finally, if you want to learn more about optimization technique, please come and discuss with us. We are also interested in, how image generation can be applied in your games. Yeah, also we have LLM chatbot demo behind the wall, and then yeah, please come and discuss with us. So yeah, we are also currently working on further optimization, and we hope to share more detailed information soon on this ARM Developer Hub platform. You can find many other useful guides, tools, documentation from here too. So yeah, that's my talk. Thank you for your time.